Stonehenge is a masterpiece of prehistoric European architecture. Built around 4,500 years ago, the imposing stone circle has withstood the test of time and continues to awe everyone who visits. What not many people will be familiar with is its potential connection to the moon. But to understand this, we need to first look at the sun. If one were to track the place where the sun rises every day for a year, one would see it shifting almost every day. The position of sunrise moves like the swing of a pendulum, slowing down at the extremes, when the sun rises and sets in the same place for about a week. These are called the solstices, when the sun stands still, and they occur in midsummer and midwinter. Stonehenge marks the annual movement of the sun through its central axis, a line that divides the circle and horseshoe arrangement into two equal parts. This axis aligns with midsummer sunrise on one end and midwinter sunset on the other. There is sufficient evidence at Stonehenge and its surrounding landscape to suggest that these alignments were not accidental, but intentionally built into this prehistoric site. The moon does something similar to the sun, but where the sun takes 6 months to go from one extreme position to the other, the moon takes half a month. Every day, in its cycle from dark to full and back again, the moon changes its rising and setting position, and just like the sun, its movement is contained within the marked limits. If one were to track this movement over several years, however, one would notice that these limits change. This animation shows the progression of the yearly lunar limits over the last decade, until they've reached their maximum span in 2024. This is called a major lunar standstill precisely because the moon can rise and set at its northernmost and southernmost positions. These are outside the range of movement of the sun, making them even more noticeable. Following a major lunar standstill, which lasts up to 2 years, the range of movement of the moon starts to shrink back to its minimum, eventually bouncing back again. The entire cycle takes about 19 years, so we're talking about a phenomenon that can be experienced only a few times in one's lifetime, perhaps less so for a prehistoric person. It has been suggested that the major lunar standstill is marked at Stonehenge by the station stones that were carefully placed outside of the circle, only 2 of which remain. But stone sockets found during excavation suggest there were 2 others. The station stones are sarsen, the same type of material as the tall circle uprights, although they're much smaller. The location of the 2 missing ones are indicated by markers, one of which can be seen by visitors when they first approach the circle. Together, they formed an almost perfect rectangle, whose long sides just scrape the stone circle and therefore must be part of the architectural design of Stonehenge. Another way to think about them is as being placed exactly parallel to the central axis of the circle, thereby also aligning with midsummer sunrise and midwinter sunset along the shorter sides of the rectangle. But it is down the longer sides that the moon connection can be found. When looked at it this way, the station stones align with 2 of the 4 extreme positions of the moon during a major lunar standstill, the northernmost moonset at one end and the southernmost moonrise at the other. During a major lunar standstill season, the moon will rise and set in alignment with the station stones roughly every 15 days, each time doing so on a different phase and a different time of day or night. Here is a simulation of the setting of the northernmost full moon at dawn, very close to one of the existing station stones. Looking towards the southeast and the position of the southernmost moonrise, we can also simulate the full moon rising in alignment with the station stones, but very quickly disappearing behind the imposing stone circle, its face popping up later once clear of the stones. Exploring the accuracy, context, and potential significance of these alignments are the aims of an ongoing collaborative research project which started in early 2024. This involves the observation, measurement, and recording of moonrises and sets in alignment with the station stones, often in the middle of the night and under very cold weather. Cloudy conditions have prevented us from seeing the moon on a number of occasions, but there will be plenty of more opportunities until late 2025. Once the project is concluded, the results will be made public, so keep an eye out for them in the near future.